All right, thanks for rejoining us, or me. We're still talking about graphing polynomial functions. This was the problem that we went through. So we want to write the end behavior of the polynomial. You want to state the degree, whether the degree is odd or even, and then whether the sign in front of the leading term is plus or minus. And then we also want to talk about the end behavior. Yeah, right, the end behavior. Okay, so as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. The degree, at least in this case, is 4. I have 1, 2, 3 turning points. And because this faces down, 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 the sign is going to be negative. Right, so this brings us to our third classwork problem, excuse me. So write the end behavior of this polynomial, state the degree, and whether the degree is odd or even, and then whether the sign in front of the leading term is plus or minus. Sorry about that. So I'm going to bring you back. You can copy this down, please. And then I'm going to move on. Okay. So next thing we want to do is evaluate a polynomial function at a given value of x. All right, so this says evaluate the polynomial with a given value of x. So we're going to substitute 3 in for x and evaluate this number. So essentially what we're finding is the point for the graph of the polynomial where x is equal to 3. So we substitute 3 in for x and then solve. Of course, remembering our order of operations, we want to evaluate the exponent first, then multiply, then subtract. Whoops, I skipped through this. All right, so I'm going to substitute 3 in. I'm going to take that to the 4th power, it's 81. 3 to the 2nd power is 9. And then 3 to the 1st power is just 3. I'm going to multiply the terms and then subtract and add them, combining like terms, and end up with 98. So f of 3, then, we would write it as this. F of 3 is equal to 98. Or we could say at x is equal to 3, y is equal to 98. Or we can also say that 3, 98 is a coordinate. All right, so that's what we just did. When we're evaluating a given number, what we're doing is we're finding the value of y, given that value for x. And ultimately what we're finding is the coordinate for that function. All right, so you want to evaluate the polynomial with a given value of x. So please take a moment to do this. I'm going to give you the answers, then I'm going to give you some classwork to do. So you can pause here, do the work, and then I'm going to show you your answers. Okay, for the first one, f of 4, substitute 4 in for x. Now remember, this negative sign is like a negative 1 times 4 to the power of 3. So we're not going to apply that negative sign until after we've taken the 4 to the power of 3. That becomes negative 64. So 4 times 4 is 16 times 4, 64. So that's 4 to the power of 3. 4 squared is 16 times 3 is 48 plus 9. And I end up with negative 7. So f of 4 is negative 7. And then evaluate when x is negative 2. So negative 2 to the power of 5 is 2, 4, 8, 16, 32. That's going to be a negative value because as I multiply negative 2 5 times, so negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 is 16, times negative 2 is negative 32. So it's 3 times negative 2. And then I have minus 2 to the power of 4, which is 16. Minus 16 plus 12 plus 10. I have negative 102 or 112, excuse me. Plus 22 is negative 90. All right, so that brings me to our 5th classwork problem. I'm going to give this to you and leave it up. Please pause the video here. Write this question down, and then I'm going to move on. Okay, last thing we need to cover is graphing polynomial functions using a table of values. All right, so now this is where we put the pieces of the puzzle together. So there's going to be some interpretation that needs to happen. So let's go through an example, and then I'm going to have you do one. So we're going to graph a polynomial function using a table of values. So I have these points, and I have this polynomial function. We know it's a cubic. We know it's negative, so it's going to be up to down with 2 turning points. All right. So we're going to plot in -2, 3, -1, 4, 0, -3, 1, 0, 2, -1. So that's the first thing we want to do is we want to plot these points. So we draw them on a graph, and then we recognize we've got an up-down cubic. All right, we've learned that from the previous part of this lesson. So hopefully you have your notes in front of you because you're going to need to consolidate information, bring it together to answer these questions. All right, so now I know it's up-down. I have point, 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 and point here. Okay, and I know that this function has to cross the x-axis in potentially 3 locations. It could be just 2 touching the graph. So then I'm going to draw my lines. I know I'm moving the line where it is, and now I know it's increasing here. It's a possibility that the graph goes through this line and then back down, but I'm going to say it bounces off the graph, but at least touches it here and then goes back down. This is the information that we have. So we're just trying to sketch a general idea. It doesn't have to be exact, but we're using those points and our understanding of how this cubic function looks in order to connect the dots in a way that's somewhat close to what it actually is. All right, so this brings us to classwork 4.1.6. So remember, step 1, plot the points. Step 2, identify the type of polynomial and how it is going to look overall. That's what we just went through. So I'm plotting the points. I identify how it looks overall. And then I'm going to use that overall function, try to use the points to match what this function should look like. All right, so it brings us to 6th classwork problem. I think this is the end of our discussion. So I'm going to have you use this table of values and then graph the polynomial function x to the power of 4 minus x cubed minus 4x squared plus 4. So plot these points here. Take a look at how this should look. I have a positive value here. It's a quartic. So you know what the end behavior is, and generally how it should look. And then you're going to connect the dots to make a meaningful representation. After you do that, you're more than welcome to check Desmos, but try it on your own. I'm not looking for perfection. I'm just looking for a sketch. And so roughly the sketch should match how this quartic function should operate. All right, and then you can modify after you take a look at Desmos if you want. All right, so that's it. This is your last classwork problem. Thanks for joining. Come back and join us next time when we continue our discussion about polynomials.